addition to using the horizontal line test and algebra to check if a function is one-to-one, we can also sometimes use the derivative. If we have a continuous function whose derivative is always positive or always negative, then it has to be a one-to-one function. And the way we can see this is using the mean value theorem from Calc 1. Recall that if we have a function which is differentiable on an interval, and we have two numbers x1 and x2, for which f of x1 equals f of x2, then there has to be some point c between x1 and x2 where the derivative is 0. Therefore, we can't have two numbers x1 and x2 which violate the condition for one-to-oneness if a function always has a strictly positive or a strictly negative derivative. So this gives us a new way to check if a differentiable function is one-to-one. Namely, we calculate the derivative, and if we can tell that it's always positive or always negative, we can conclude that the function is one-to-one on that interval. Note if a function is not differentiable, or if its derivatives are not all strictly positive or strictly negative, then we can't apply this test. So let's look at a function. Suppose we take f of x as the square root of 4x plus 4. That's 4x plus 4 to the 1/2. Is this a one-to-one function? Well, if I take the derivative of this function, I can use the chain rule. I start with the power rule, and I differentiate with respect to what's in the brackets. I get 1/2 times 4x plus 4 to the minus 1/2, and I multiply that by what I get when I differentiate what's in the brackets. So I end up with the derivative of 2 over the square root of 4x plus 4, which is always positive on the interval from -1 to infinity. So therefore this function is one-to-one on that interval, and the domain contains one more number, -1, but f of -1 is 0, so this doesn't coincide with f of x for any x in the interval from -1 to infinity, so we can conclude that our function is one-to-one.